Welcome to the Deep Dive. Today we're digging into SQL. Now, SQL, structured query language, maybe sounds a bit technical, just for databases.
Yeah, people often think that.
But we're going to show you how it's, well, actually a superpower for understanding data.
Yeah.
Really getting those key insights fast.
Exactly. And we've got some great sources for this deep dive. There's a really solid tutorial that lays the groundwork and also an advanced guide that's laser focused on using SQL for, proper data analysis.
Okay.
Together, they really shine a light on how SQL helps you pull out meaningful stuff from all sorts of data.
So our mission today, unpack practical techniques, maybe some surprising uses for SQL you hadn't thought of, and get into that strategic thinking behind really effective data analysis. Whether you're just starting out or you're looking to level up your skills, you're definitely in the right place. Let's get into it. Okay, so to kick us off, SQL. What exactly is it?
Oh, it's the language, right? The language you use to talk to relational databases. That's where so much structured information lives today.
Asking for data, organizing it.
Exactly. Asking, organizing, transforming. It lets you do all the core stuff like adding things up, filtering out what you don't need, sorting it the way you want.
And it's everywhere, right? Finance, marketing.
Well, yeah. Finance, marketing, healthcare. It's fundamental in so many industries.
It's interesting. One of our sources shared a story about how they got into data analysis, kind of stumbled into it.
Yeah, that resonated with me too. They talked about dealing with big data back when that meant like tens of thousands of rows in Excel.
Wow, waiting for those VLOOKUPs to finish.
Totally. Waiting for the computer to just grind through it. And then they saw SQL running on a manager's laptop, accessing this little data warehouse. It was a game changer.
Yeah.
And it really highlights how that kind of expertise used to be sort of locked away, with just a few people or teams.
Right.
And a big goal now with resources like the ones we're looking at, and hopefully this deep dive, is to kind of democratize that knowledge, make these tools more accessible.
That makes sense. And that personal story really connects to the bigger picture of data analysis today, doesn't it? It's this mix of serious computing power and, well, old school statistics. And the whole point is better decisions for people, obviously, but increasingly for machines too. So with all the data out there, why SQL specifically? What's the big advantage?
Well, the simple fact is most of the world's structured data already lives in databases.
Okay.
And loading data into databases is just way more efficient, storage-wise and processing-wise, than trying to juggle tons of spreadsheets.
Right.
Plus, computing power has exploded, cloud databases are common, so those days of waiting ages for a query to run, they're mostly gone. And SQL isn't alone either. It plays really nicely with other tools analysts use, like R or Python.
Which leads to a really key point from the sources, something maybe unexpected. Data analysis. It's not just a project you finish.
No, they call it a way of life.
A way of life.
Yeah.
A continuous journey, right? Discovering, refining, always asking better questions. And that journey pretty much always starts with getting your data ready, data preparation. Why is that step just so critical?
Because honestly, if you skip it or rush it, your analysis could be completely off, just meaningless.
Right, garbage in, garbage out.
Totally. In databases, you've got different data types, strings for text, numbers, true, false logical types, date and time info. SQL is particularly good with structured data. That's where everything has its place, customer name in one column, price in another, each customer order on its own row. Nice and neat.
Okay, but here's a practical problem. Massive data sets.
Yeah.
How do you explore that without, bringing the whole database to its knees? How do you avoid killing the database?
Yeah, that's super important. When you're just exploring, the limit clause is your absolute best friend.
Just pack it on the end.
Yep. Limit 100, limit 1,000, whatever makes sense. It just grabs a small sample so you can test things quickly.
Okay.
For slightly more sophisticated sampling, if you have numeric IDs, you can use the modulo operator, like get every 10th record. Or if you have text-based IDs, you could use something like the write function to grab records based on the last few characters. It lets you test queries without waiting forever.
Smart. So once you have a manageable chunk where you're ready for the whole thing, what's next for really understanding what's in there?
Data profiling. It's all about getting familiar with your data. What does it actually look like?
How do you do that?
You look at distributions. Histograms are great, simple frequency counts. You can use case statements in SQL to group values into logical bins or categories.
Okay, like age groups or something.
Exactly.
Mm.
And for more precision, there are advanced window functions like n-tiles. They let you split your data into equal groups, quartiles, deciles, percentiles to really see the spread.
Got it. Now, data quality,
Yeah.
always a headache. What common problems does SQL help fix?
Oh, plenty. Duplicates are a big one. You can zap those using distinct or by grouping by all the fields. Inconsistent values like USA, United States. Case statements are brilliant for standardizing those. Or for creating Boolean flags like is active and wrong data types like a price stored as text with a $sign. Cast E or the double colon operator lets you convert that into a proper number so you can actually do math with it.
That makes sense. What about the bane of every analyst's existence?
Hmm.
NUL values. Missing data?
Ah, yes. NULLs, they can really mess things up silently if you're not careful.
So what can SQL do?
Coalesce is super useful. It lets you swap out a null with a default value. Like if the email is null, put in unknown.
Okay.
And the flip side is nullif. Sometimes data uses placeholder values like 999 to mean missing. Nullif lets you turn those specific values into proper NULLs.
Ah, interesting.
For bigger missing data gaps, sometimes you might fill them based on other data or use lag and lead window functions. These let you look at the previous row, lag, or the next row, lead.
So you could like fill forward a value.
Exactly. Fill forward, fill backward. But you always need to be aware of the assumptions you're making when you do that.
All right. Good point. Okay, last thing on prep. Shaping the data. It often needs to look different for report versus, say, a machine learning model.
Definitely. SQL is great for reshaping. You can pivot data using case with aggregations. That takes rows and turns them into columns, kind of like an Excel pivot table. Great for summary reports. And you can do the opposite, unpivot. Take data that's wide and make it long and skinny using union statements. That often gets you to what's called tidy data.
Tidy data?
Yeah, where every variable is a column, every observation is a row, every value is a cell. That format is ideal for stats packages and machine learning tools. SQL helps you get there.
Okay, we've prepped our data, but so much analysis involves watching things change over time. That brings us to time series analysis.
Yeah, huge area.
And it's just data points logged in time order, right?
Yeah.
Daily temperature, stock prices, stuff like that. SQL must be good for this.
It is, but time data definitely has its quirks.
Like what?
Well, time zones for one. Is that timestamp UTC or local time? Logging something at midnight locally might actually be the previous day in UTC, you know? You can lose context.
Oh, right. I can see that.
SQL has functions to handle all sorts of date and time conversions, though. You can extract specific parts, the month, the hour, the day of the week, using extract or date part.
Okay.
And you can do math with dates, like calculating the duration between two timestamps using intervals or the age function.
So let's take a real-world example, like the U.S. retail sales data mentioned in the sources. How does SQL help us find trends or seasonality in that?
Well, you can calculate simple trends easily. Compare different parts of the data, like men's versus women's clothing, using basic math, differences, ratios, percent change. You can also index the data, pick a starting point, like the first month, and express everything else relative to that using functions like first value.
Okay, see how things have grown since the beginning.
Exactly. And calculating percent of total is really revealing. Like, what percentage of total clothing sales were men's versus women's each month? That often shows strong seasonal patterns. Sometimes those patterns even fade over time, which is interesting too.
And what about things like moving averages, like a 12-month rolling average or year-to-date sales?
Yeah, those are super common. And SQL's window functions make them way easier than they used to be.
Easier how?
Before window functions, you often had to do complicated self-joins, joining a table back to itself. Window functions let you calculate those rolling or cumulative values directly. Much cleaner.
Nice. So let's dig into seasonality a bit more, these repeating patterns.
Right. Patterns that repeat over predictable periods. Yearly, like holiday sales, or day of week, maybe website traffic, even time of day.
How do you spot it?
Often, just visualizing helps. Aggregate the data by month or by day of the week and look for peaks and valleys. The sources mention great examples. Jewelry stores peaking in December.
Holidays, yeah.
And bookstores having 2 peaks. August for back to school, and then Decjan for holiday gifts.
Right. Makes sense.
To see the underlying trend without the seasonal noise, SQL helps you benchmark. You can use the lag function to easily compare this month to the same month last year.
Ah.
Or you can pivot the data, maybe put each year in its own column using date, part, and aggregation to compare periods side by side. Helps you cut through that seasonal fuzziness.
Cool. Okay, let's switch gears a bit. Understanding user behavior. Cohort analysis comes up here.
Yes, very powerful technique.
It's about tracking groups, right? Like
Yeah.
customers who signed up in the same month and seeing how they behave over time compared to other groups.
Exactly. Tracking and comparing groups often defined by when they first showed up or did something specific.
But there's a potential trap here.
A big one, survivorship bias.
Okay, what's that?
It's when you only focus on the ones who survived, the customers who stuck around, the users who didn't churn, and you ignore everyone who dropped off.
Ah. So you get a misleading picture.
Totally misleading. Your conclusions might look way too rosy because you're only looking at the successful ones, not the whole picture.
Good warning. Okay, shifting again. Unstructured words, text data. There's so much of it. Logs, support tickets, social media. How can SQL help us make sense of all that text?
Well, first, it's important to know what SQL is good for with text. It's mainly quantitative text analysis.
Me.
Meaning things like categorizing text, pulling out specific pieces of information, counting words or phrases. It's not really for deep qualitative understanding of meaning.
Got it. More about structure and frequency.
Exactly. The sources use this amazing UFO sightings data set as an example.
UFOs. Seriously.
Seriously. And they show how functions like left, right, split part to break, text up, replace, and trim to clean it up can pull structured info out of those narrative reports, like extracting the state or the reported shape of the object.
That's pretty cool, but what if the patterns are more complex?
Then you bring out the big guns. Rejects. Regular expressions.
Right. Regex lets you define really specific patterns to search for, even in messy, inconsistent text.
Precisely. In SQL, you often use the symbol, the tilde, for regex matching.
And what are the key bits of regex?
Well, the bottle period is a wildcard for any single character. Square brackets let you define character sets, like 09 for any digit, or AZ for any lowercase letter.
Okay.
Quantifiers like plus mean one or more of the preceding thing means 0 or more. And things like way mark word boundaries, so you match whole words.
So you could build a pattern to find, say, dates written in different ways within the UFO reports.
Exactly that. Or pull out location names, even if they're spelled slightly differently. Regex gives you that power within SQL.
Powerful stuff.
Okay.
Next up, anomaly detection, finding the weird stuff in your data.
Which is crucial. Anomalies happen all the time. Data entry mistakes, maybe a process changed how things get logged. Sometimes data gets duplicated by accident.
So how does SQL help find these outliers?
Several ways. Simplest is just sorting your data and looking at the extremes, the highest and lowest values.
Get a sense.
You can calculate percentiles using functions like percentile count or median to see where a value sits in the overall distribution. Is it in the top 1%?
Right.
Calculating standard deviations and z-scores tells you how many standard deviations away from the average a data point is. That's a common statistical way to flag outliers.
And visuals help too, I imagine.
Hugely helpful. Graphing the data often makes anomalies jump right out.
And anomalies aren't just extreme values, right?
No, they can take different forms. Outlying values, sure, but also unusual counts or frequencies, or even the absence of data where you expect it.
So once you find them, what do?
First, investigate. Why is it anomalous? Is it an error or something real? Then you might remove it, or maybe replace it with a calculated value using coalesce or case. Sometimes you might rescale the data to lessen the outlier's impact. The earthquake magnitude example in the sources shows some of this.
Got it. Okay, moving towards the gold standard for figuring out why things happen, experiment analysis, A/B testing.
Right. This is how you try to establish actual causality, that doing X really causes outcome Y. Not just that they happen together.
And the sources use a fictional mobile game experiment.
Yeah, a good illustration. You set up your control group A and your variant group B. Maybe B gets a new feature. Then you measure success. Did more people in group B finish onboarding or spend money?
Sounds straightforward, but I bet there are pitfalls.
Oh, definitely. Common challenges. First, sample size. You need enough users in each group for the results to be statistically meaningful, not just random luck.
Okay.
You have to guard against bias and how users are assigned. Did all your highly engaged users somehow end up in group B before the test even started? You need to check that.
Ah, yeah.
Then there are things like novelty effects, people trying something just because it's new, not because it's better long term, and regression to the mean, especially if you run tests repeatedly.
What about AA tests?
Yeah, running an AA test where both groups get the same experience is a great sanity check for your testing setup before you launch the real experiment. Make sure the system works and there aren't weird pre-existing differences.
Makes sense. But sometimes you just can't run a perfect controlled experiment, right? Ethical reasons, practical limits.
Exactly. It's often not feasible.
So what do you do then if A/B testing is off the table?
You have alternative analysis methods. They require more caution, but they can still give insights.
Like what?
Well, there are natural experiments. You find naturally occurring groups that are already different in some key way, like maybe a promotion ran in Canada but not the US.
Hmm.
You can compare those groups, assuming they're similar otherwise.
Okay.
Another is regression discontinuity design. You look at populations right around some threshold, like people just above or just below cutoff for a program, assuming they're very similar right near that line. But with these methods, you have to be super careful about confounding factors. Other things that might be influencing the outcome besides the thing you're studying, it's much harder to isolate causality.
Right. Makes sense.
Okay.
Okay, let's talk about building data sets for ongoing use, not just one-off analysis. Creating complex data sets. This must mean well-organized SQL is key.
Absolutely essential. If multiple people or processes are going to use this data set, the code needs to be maintainable.
And there's a trade-off sometimes, right, between putting logic in the ETL process, the extract, transform, load pipeline, versus keeping it in the SQL query itself.
Yeah, exactly. Building logic into ETL can be more performant if it runs regularly, but keeping it in SQL queries gives you more flexibility for quick changes and iterations. It's a balance. But regardless, the SQL itself needs good code organization, proper commenting, consistent style like capitalization, using indentation wisely, and really understanding SQL's order of operations helps write efficient queries. Like building anything complex, the structure matters.
And there are SQL features that really help with that structure and complexity, like temporary tables and column table expressions, or CTEs.
Yes, especially CTEs. They make complex queries so much more readable and often more efficient.
How do they work, basically?
You use the why-with keyword to define a named temporary result set. It's like breaking your query down into logical name steps. You define a CTE once, maybe doing one piece of logic, and then you can refer to it by name later in the main query, even multiple times.
Like building blocks.
Exactly.
Yeah.
It stops you repeating the same subquery over and over and makes the whole flow much clearer.
And what about getting summaries at different levels, like totals and subtotals in one go?
Yeah, SQL has features for that too. Things like grouping sets, QBB rollup let you generate multiple levels of aggregation grand totals, subtotals by region, subtotals by product line, all within a single query, which is way cleaner than writing multiple separate queries and sticking them together with union.
Very efficient. Okay, finally, as we create and share these data sets, two big considerations always come up: size and privacy.
Absolutely critical.
How do we manage data set size if the downstream system can't handle everything?
Well, you might use careful sampling, like we talked about earlier. Or you could transform detailed data into simpler flags or categories, reducing the granularity.
And the big one, data privacy.
Paramount. Ethically and legally, you need strategies like anonymization or obfuscation, replacing sensitive data with realistic but fake data or redaction, just removing it entirely, especially for PII, personally identifiable information.
Anything that could identify a specific person.
Exactly. Names, addresses, social security numbers, that stuff needs incredibly careful handling to protect individuals' privacy.
Wow. What an incredible journey through SQL. We've really seen its range, haven't we?
Yeah.
From the basic cleaning and profiling, all the way to sophisticated time series, text analysis, spotting anomalies, even analyzing experiments. It really is a core part of the whole data analysis toolkit.
It truly is. And maybe a final thought for you to chew on as you continue your own data explorations.
Yeah.
How can cultivating this data-informed mindset, this continuous journey we talked about, how can it not only help us understand the past, but actually empower us to ask new and harder questions? Questions that really drive innovation and push the boundaries of what we know.
That's a great thought, asking harder questions. It reminds me of that amazing detail about the green magpie in the source materials notes.
Oh yeah, the colophon.
Right? How its feathers are this vibrant green because of carotenoids from its diet. But if something changes that diet or its biology, the color can shift dramatically, become turquoise even. And it feels like our understanding of data is like that. It can seem one way, but when you apply these different SQL techniques, when you really examine it critically,